For this test, we're going to focus on our third and final type of t-test. Specifically, it's called a paired samples t-test, and I'd like for you to have 3 documents available. The first one, which you should see on this display, is from the file called t-test graphics, and then I would like for you to have output A and the test from the document with all the analysis that shows what to run to get output A. If you'll think back to the framework that I've been trying to drive home through these different modules, you ask yourself these questions. In your test, what's the key word in the question in output A? The sentence says, is there a mean difference between this sample of teachers' reports of teacher influence, which is called TQ25, and parent influence, which is called TQ11 in school decisions? So in other words, we asked teachers on a survey, how much influence do you think you have over certain decisions, and how much do you think parents have over those decisions? But it's one sample. It's one sample, it's teachers, and it's 2 variables, parent influence and teacher influence. The key word that we focused in on is there a difference? That tells me I'm in a causal comparative model. So again, I ask myself, how many groups, how many samples, if you will? 1, it's all teachers. How many variables? 2, parent influence and teacher influence. So that tells me I have a paired samples t-test. I have a pair of variables that I ask questions from a single group. So if you look at this graphic, it's much like the other 2 graphics. We just need to think what's in the numerator first. What we're going to do is we're going to take the mean of all the teachers' answers to the parent influence questions and calculate that. And that mean comes up to a 2.2352. We do the same thing asking teachers about their own level of influence, and that mean came up to 2.7279. The difference between those 2 means is negative 0.4927. So that question is basically in the numerator, is that mean large enough to be far enough away from 0 to consider there to be a statistically significant difference between those 2 means? So what I'd like you to do is to open up your database that's in the K-12 data that is called Teachers Edited. With that database open, if you go to your first weekend means comparison file and you look at output A, you'll see that question that I just read. Is there a mean difference between this sample of teachers' reports of teacher influence and parent influence in school decisions? So the variables are almost always at the bottom of a database. What TQ25 represents, there are several questions that make it up. So teachers were asked, how much influence do you have over the budget? How much influence do you have over hiring teachers? How much influence do you have over what you teach, over the curriculum, and so forth? And all those questions are averaged together, and that's how we get one variable from the average of several items. That's TQ25. The same thing teachers were asked parents on these same questions, and then those were averaged. So what I'm going to do, I'm going to go up to Analyze. I know I'm in causal comparative, so I'm going to go down to Compare Means, and I know I'm in a paired sample t-test because I have one sample with 2 paired variables. So I'm just going to click OK, and the variables pop up for pair 1. I'll go down to the bottom and I'll see TQ25, teacher influence, and I double click, and it moved over to variable 1, then I'm just going to go about 5 spots ahead of that, and I'm going to click on parent influence and click OK. And that's all I need to do. So now if you look at the outputs, it should be roughly comparable. It's a little bit different database. It's not going to perfectly match what's on the printouts, but it's very, very close. There's a small difference in the sample size. But I look at this output and I can say, teachers think on average that they have a mean level of influence of 2.7339. There were 1,145 teachers, and then they asked how much they think parents have, how much influence they think parents have, and that came up with a mean of 2.2376. I go down here and I say, parent sample t-test, what's that mean difference? 2.73379 minus 2.2376 gives me a mean difference of 0.49626. So I can scroll across and I see a t-value. That mean difference is associated with a t-value of 29.868. Is that t far enough to be outside of the lower and upper t's? So 95% roughly, 95% of the time, if you ran this same test, you would get t-values between 0.46 and 0.52 if there was no statistical difference. But we got a t-value of 29.8, which is way outside of that. This value is very, very significantly less than 0.05. So we conclude there is a statistically significant difference. So the way we would word that is we would look back up at our descriptive statistics in the first chart, and we can see that teacher influence was higher number than parent influence. And so you would say teachers in these districts report that they have greater influence, and you could, in parentheses right after that, say mean equals 2.7339, then parent influence 2.2376. That's all I need to say, because when I say higher or more or greater influence, that tells you that it was statistically significant. So you, in the interpretation, that's all you need to say. If you wanted to write this up, you could say something like, a paired sample t-test was conducted in 5 districts across 3 states. 1,145 teachers were asked to describe their level of influence in school-wide decisions compared to the level of influence that they believe parents have. Teachers in these districts reported that they have greater influence over school-wide decisions than parents do. And you would then say T in parentheses at the end, T equals 29.868, comma, significance equals 0.000.